Okay, let's get started by creating a constructor function for our binary search tree. We will say function BST, and it will take in a value as a parameter. We will have three properties on our binary search tree instances: a value property, a left property, which will refer to the left child node, and a right property that will refer to the right child node. We will set the value property equal to the value parameter that is passed in. We will set the left child property equal to null initially. And we will set the right child property equal to null initially as well, because we will use our insert function to assign the left and right child nodes. Okay, great. So that is our binary search tree constructor function, and we will make all of our nodes, or binary search trees, with this constructor function. So, as an example, if I write variable BST equals a new binary search tree with the value of 50 passed in, I have just created a binary search tree of one node with no child nodes. As a guideline for this section, and to help us conceptualize what is going on, I will put a diagram of a binary search tree in the lower right-hand corner of the screen. This is the binary search tree that we will be creating and working on for this entire section. So let's put our first method on our binary search tree. The first method we are going to create will be the insert method. So we will say bst dot prototype dot insert equals a function that takes in a value as a parameter. What this method will do is it will take in a value, make a new binary search tree or node with that value, and place that node into our original binary search tree at the correct location. And throughout this section, I will often use the terms binary search tree and node interchangeably. And the reason for that is that all of our nodes will be made with the binary search tree constructor function, and they will initially be created with no left or right child, so they will essentially be a node. Now, how does our insert function work? Well, the first thing that we are going to have to consider is the value that we want to insert less than or greater than the value of our root node? If the value that we want to insert is less than or equal to the value of the node that we are acting on, in this case the root node, we will want to do one thing, and if it is greater than the value of the node, we will want to do something else. And I could take out this if part right here and just leave it as an else block, but I will leave the if in just to be explicit and so that it is easy to tell what we are doing as we move forward. Let's start with the case that the value that we want to insert is less than the value of the current node. If it is less than, we know we want to move to the left. Now, there are two cases that we have to consider here. Is there already a left child node there, or is the left child currently unoccupied or null? If there is no left child, then we simply set the left child, or this dot left, equal to a new binary search tree of the value we passed into our method. If there is a left child, or else, then we are going to want to run our insert function on the node or binary search tree that is the current left child. So we say this dot left dot insert and pass in the value. Now, we will touch on what this line is doing after we handle the case in which our value passed in is greater than the value of the root node. So in this else if block, we know that the value needs to be placed on the right side of our node. So we say, if there is no right child, or this dot right, we simply say this dot right equals a new binary search tree, and we pass in the value that is passed into our method. Otherwise, if there is a right child, we run our insert function on this node by saying this dot right dot insert, and we pass in the value. And that is it. That is our insert function. Now, how is it working? Well, these two lines are pretty self-explanatory. If there is no child node where we would like to insert our new node, just put it there. Simple enough, right? Now, these two lines are saying if there is a node there, simply run our insert method on that node. And this is where our recursion comes into play. By calling our insert method recursively on every binary search tree or node that we come across, we will travel down through our tree in the correct directions, either left or right, depending on the value of each node that we come across, and we will end up inserting our new node where it belongs. This really just shows you how powerful recursion can be. If you're a little fuzzy on how this recursion is working, and you're having trouble understanding how we're actually inserting our node into the correct place in our tree, I would encourage you to just sit down and go through an example and draw out what's happening with a piece of paper and diagram it out, because I find that for myself when I have trouble conceptualizing something, it really helps to just sit down and draw out what's happening. So I would encourage you to do that. But honestly, don't worry too much if you're still a little bit unclear about recursion at this point. We will be using recursion a lot throughout the videos in this section, and how it is working will become a lot more clear as we move forward. Great, so our insert method is complete. Let's make sure that it works in the next video.